Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dinishif Zain bin Emiruddin and my metric number is GF210012. So for our group, the group 6, we present our topic which is the stormwater drainage design at Ahmad University Raja Johor. As for my part, I will explain a little bit about the introduction. The introduction. The stormwater drainage system is a facility that is a part of the infrastructure that collects the rainwater and helps to keep the metropolitan areas from becoming flooded. Stormwater drainage systems in urban contexts are dependent on a number of important elements, including the size, shape, and nature of the catchment area. The present practice dictates that the catchment area can be estimated using any one of a number of different approaches. So this is our study area. After we have do some site visit at Taman University Parit Raja, Johor, and we finally find out that the existing drainage existed by the main road approximately 491 meters long and 1.8 meters depth and 6 meters wide. The average slope along the drain is about 2 meters. And we also find out that the channel utilized the trapezoidal channel shape. By using the Google Earth Pro, we find out that the groundwater level of the drain is uneven. The flow of the water to be interrupted and cause flooding in the area. It is necessary to analyze since a suitable drain must be developed using the rational method in the specified area. The problems that we found: firstly, a suitable drainage system should be designed properly to mitigate the floods and heavy flow from overspill to the roadways, which is always happen at the Taman University when it is heavy pouring. Secondly, a suitable drainage system needs to be analyzed, including the size, shape, and the nature of the catchment area are crucial factors in designing stormwater drainage systems in urban settings. Our study objective is firstly to propose a suitable drainage system that is able to mitigate the heavy flow efficiently, and secondly, we want to analyze the direction of water flow within the drain along proposed drainage at Taman University Parit Raja, and thirdly, to determine the optimal drain system type and size along the existing drainage at Taman University Parit Raja. So that's all for my part. Thank you.
Assalamualaikum, my name is Nur Anissa binti Ruslan. I will continue for literature review part. Series of severe flooding in states such as Johor, Kelantan, Terengganu, Kuala Lumpur and Selangor, which was reported in late 2021 due to heavy rains and clogged sewage drainage. Irregular construction drain flow channel, the growth of grasses and the plants in the earth drain, little infiltration capability and the photographical condition of the study are some of the reasons for floods in Taman University Parit Raja Batu Pahat. Flooding occurs frequently when there is significant rain in a certain location and is also caused by the inefficient stormwater drainage system. The problem of flooding caused by the drainage system may be resolved if the drainage is proposed in accordance with the MSMA specifications.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Ismail and I will talk about the methodology. So there are two general steps that I use in this project. For doing the calculation, there are two main formulae or method that we use. First is the rainfall estimation method and the second one is the peak discharge estimation. Okay, for the rainfall estimation, we use the Manning equation. The Manning equation is an empirical equation that applies to uniform flow in open channels and is a function of the channel velocity, flow area and the channel slope. So the formula for the Manning equation is Q equal to 1 over N times with A time with R to the power of 2 over 3 and time with R to the power of 1 over 2. So Q is the volumetric water flow rate passed through the stretch of channel. A is the cross-sectional area of flow perpendicular to the flow direction. S is the bottom slope channel and N is Manning roughness coefficient and R is the hydraulic radius. So this is the flow of step of using the Manning equation. First, we determine the Manning roughness of coefficient. Next, we determine the cross-sectional area. Next, we determine the hydraulic radius. And next, we determine the channel slope. And next, we can get the value of Q by calculate the flow rate. Okay, next is for the peak discharge estimation. We use the rational method. So, rational method is a relationship between rainfall intensity and catchment area as independent factor and peak flood discharge. For this project, rational method is used to obtain a discharge or peak flow rate for an urban area that has been chosen. The drainage system design ARI is determined as the first step for the calculation. The formula is Q equal to CIA, where the Q is design discharge, C is the runoff coefficient, I is the design rainfall intensity, and A is watershed drainage area. Okay, this is the flow step of using the rational method. After we determine the design ARI, we find the area. Next, we find the time concentration, and after that, we find the intensity. Next is we find the runoff coefficient, and after that, we calculate the peak flow. Okay, next is the formula that we use during the rational method. So the formula shown are to obtain the TC and the TO, where the TO is overland sheet flow travel time, L is overland sheet flow path length, and N is the Horton's roughness value for the surface, and S is the slope of overland surface. Next is the formula for determine the TD, where TD is the travel time in the drain, L is the length of bridge, N is the Manning roughness value for the surface, S is the friction slope, and R is the hydraulic radius. Okay, next is the formula for calculating the I. So I is the average rainfall intensity, T is we get from the ARI, and D is the storm duration, and lambda, T and power K, and also theta is the fitting constant dependent on rain gauge location.
Hi and Assalamualaikum. My name is Nur Shamil binti Nursha. My metric number is DF210011. So today I would like to talk about our data analysis for this project. So this is our channel dimension for our project. So for the depth of this drainage or channel is 2 meters, and for the top width is 5.5 meters, and bottom width is 4.5 meters. So first thing first, we need to do these 4 basic calculation before we go to the next step, which is slope calculation and other drain flow calculation. So first is find the Z for this drainage or channel, and then the second one is we need to know the area for our drainage. And the third one is weighted perimeter. We need to calculate the weighted perimeter for our drainage. And the last one is hydraulic radius. So this is our catchment area and elevation profile for our project. So the highest elevation value is 10 meters, and for the lowest value of the elevation is 8 meters. And the length of the channel is 483 meters. Okay, so at this step, we need to calculate the friction slope by using the formula given, which is highest value of elevation need to minus with lowest value of elevation and then divide by length of channel. So our value for slope friction is 0.0041 ampere amp. So after that, we need to determine our Manning roughness value. So based on the channel's side and the nearby the drainage, we choose the tall grass cover. It is 0.050 value for Manning roughness. So after we determine our Manning roughness and we assume our ARI and so on, we need to calculate for drain flow, which is our drain flow value is 5.7 minutes or 0.095 hours. So the next step is overland flow, which is TO, is equal to 50.15. So our time of concentration, it is the same value with D. So our TC or D is 55.85. So for this one is IDF empirical equation, or the table for IDF equation, empirical equation. So from this table, we need to choose, or we need to determine which location of station is nearby for our project station or area. So we choose sector JPS Batu Pahat, which is it is near for our project, and we need to we can get the constant that given. So by the constant value, we can using it at calculation of average rainfall intensity. So for this step, we need to calculate the rational method for our catchment area. So based on the table given, we need to determine which one our runoff coefficient value. So we need to know our channel is nearby with what land use. So we choose the commercial and business, which is it is the most suitable for our location of project, and then we apply it to our calculation, which is discharge QP. So our coefficient is 0.95 because our ARI also more than 10 years. Then our QP value is 0.056 m power of 3 per s. So the last step is to propose the new building. The innovation that we use to this new building is we add the depth, which is 2.5 meters, 0.5 meters longer than the old building, and then we also add the bottom width is 5.0 meters. So like the earlier step, we need to calculate the Z areas and perimeters, and also the hydraulic radius for our channel before we continue to the next calculation. So after we got uh, all the value before, we can substitute and apply it on this formula, which is discharge design flow, or Q design, for our project, to know which is our Q design is more better than Q peak that we got before. So our Q design is 18.66 m power of 3 per s. So if we can see, the Q design is more bigger than QP. So it can manage to support or to mitigate the flood that bef- that can occur the project sites.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Daniel bin Muhammad Razani. My matrix number is DF210020, and I'm going to present about the discussion for this project. Okay, in this project, there are a few questions that we need to answer for the discussion. For the question number one is a flash flood occur. Okay, flash flood is the flooding that happen quickly following a participant event, usually within 6 hours. It happened during periods of heavy rainfall, and it will affect the drain and sewer that cause volume of water exceed the allowed capacity. This flash flood can occur without any warnings, and can damage houses and also business property. Okay, for the second question for the discussion, the flood mitigation method. Okay, for flood mitigation method, there are two ways that we can use. First is structural flood mitigation, and second is non-structural flood mitigation. Okay, the structural flood mitigation, the method that we can use is the improvement of the infrastructure, including dam, lifts, bridge, and also culverts. We need to understanding about how will each measure will affect flood mitigation. This is important because it can prevent flood disaster before it become worse, and it may help people to reduce the damage to the houses and also properties. Okay, for the non-structural flood mitigation, the method that we can use is to do the planning for land usage. The strategic land, such as commercial and industrial property, will define the amount of flood impacted area. The all new development area must conduct land suitability evaluation to find out how much land is limited. This was to make sure that there was not be the creation of wasteland and can prevent the usage of land that can increase the risk of flood disaster. Okay, for the third question is to propose a new design. Okay, after we do some calculation, we have create or we have designed uh, a new channel that can sustain the drainage, the volume of water in the drainage. Okay, for our new design, what is the difference between the new design and also the old design is the length of the base for the channel got bigger compared to the old design. This is because it can help the channel to accommodate the water to prevent flooding, to prevent from flooding. The discharge value for the new design will be bigger than the discharge peak of the old channel, which is 18.66 m cube over seconds compared to the 0.056 meter cube over seconds. This new design will be able to control the volume of water in the channel, and we hope it can prevent the flooding before it spreads into many areas.
Okay, for the last part is the conclusion. So, in conclusions, the new proposed design for channel drain is the solution for flood issues that often occurs in the Taman University Pariaja. The new proposed design for channel drain are determined when by doing the calculation Q design is greater than Q peak. So when we doing the calculation and the analysis, to generate the new proposed design, the Q design must greater than Q peak, so the new proposed design can withstand the Q peak. Other than that, the advantage of the new proposed design is it can prevent water accumulation. So the accumulated water can make the soil muddy, which can cause the soil to disintegrate. So the new drainage system can keep soil moisture regulated and also can reducing the soil erosion. Next is the Stormwater Management Manual Malaysia MSMA play an important role in stormwater management implementation. The calculation to develop the new proposed design by our group as referring the MSMA to make sure the drainage system in the study area cover most of the important aspect and the requirements.